This video is describing how to find quantum numbers based upon what we discussed in class on Tuesday. Let's go ahead and get started. I'm going to provide two examples, an easy one and a hard one, and you should be able to follow the rest from there. So I'm going to start with an easy element. In this case, let's do fluorine. And we also want to grab the electron configuration of the element. So in this case, 1s2, 2s2, 2p5. So let's go ahead and write that down. We have fluorine. We have 1s2, 2s2, 2p5. I'm going to rewrite that. 2p5. Perfect. Okay, so your principal quantum number is the one that's first. All of the information that you're going to get from this is going to be based upon this last thing in your electron config. You can ignore everything that precedes that. So n is going to be equal to the number that is leading your orbital that you're in. So in this case, 2, n is going to be equal to 2. Next letter we have is L. L can be anywhere from 0 to n minus 1. So in this case, if our n is equal to 2, L can be equal to either 0 or 1 because it cannot be equal to n itself. The easiest way to find that is to look at the orbital that you're in. In this case, we're in a p orbital. And I'm going to refer to this. We can see that if we're ending with a p orbital, our number is going to be L. So we're going to go ahead and write that down. L is equal to 1. If I cut back here, if we have S, it'll be 0. If we have D, it'll be 2. If we have F, it'll be 3. All right, good. So now we're going to move on to M sub L. In this case, we're just going to call this M. Now, M can be equal from anywhere from negative L to positive L. We have that L is equal to 1, so it has to be greater than negative 1, which in this case is negative L. But it can't be greater than, it can be equal to just regular L, which is 1. So just think about this as positive L. Here's M in the middle. The easiest way to find this is to take the orbital that you're in this case P, and think how many electrons can the p orbital hold? We know that the p orbital can hold 6 electrons. And we know that 6 electrons is going to make 3 pairs. So we're going to go ahead and draw 3 boxes right here to demonstrate. All right, P. Now this, because it can be between negative 1 and positive 1, we're going to go ahead and label from left to right. This is going to be negative 1. This is going to be 0. And this is going to be positive 1. If our M could be between, say, negative 2 and positive 2, this would actually be a d orbital, because a d orbital can have up to 10 electrons, which means 5 pairs, which means you have room to add that extra negative 2 and positive 2 on the end. But in this case, just a p orbital. Then you want to take the number following the orbital you're in this case 5, and you want to go ahead and write each of those electrons in the boxes. So we're going to start with our first one, second one, third one. And you always go from left to right, and you'll write all of your ups and then all of your downs. So that's 3 of them. That's the 4th. That's the 5th. You want to go ahead and see what number am I above because of my last electron. In this case, we're above 0, which means that M is equal to 0. We can see that that does in fact check out. 0 is between negative 1 and positive 1. Really good. All right, now M sub S, also just referred to as S, is the easiest one. I want to go ahead and take a look at our last electron again, and we want to see, is it going up or is it going down? If it's going up, it'll be a 1/2. If it's going down, like this last one is, it'll be a negative 1/2. So we get that the ground state fluorine is going to have an electron, or is going to have the quantum numbers 2, 1, 0, and negative 1/2. Let's go ahead and pick a harder example. I'm just going to erase a lot of this. I think that should be good. I'm going to go ahead and write in my M and my S, and let me just erase this. Okay, now we're going to do something like titanium. So let me just get writing. We'll do this over here instead. So titanium, we're going to go ahead and look at the periodic table. We have 1s2, 2s2, 3s2. We're going to be on the 4s2. We don't care about any of this stuff going before it. We just need to just know what s orbital we're starting with. So because we're starting with 4s2, I'm going to go ahead and write argon. so I don't have to write the rest of this. I'm going to go ahead and write argon, and then we are 4s2, and then I'm cutting into the red block here, which means we're in D. We are 1, 2 in, so we are 3d2. 3d2, good. Okay, same thing follows. To find n, we're going to go ahead and look, or to find all of these numbers, we're going to go ahead and look at the last little bit of the electron config. So n is going to be the number preceding your orbital, in this case 3, so n is going to be equal to 3. We know that our L is between 0 and n minus 1, which means our L can be between 0 and 2. It has to be between those two numbers, because it can't be the same value as n. It has to be less than that. The easiest way to find that is to look at the orbital that you're in this case D. Go over here, we can check D is equal to 2. So L is equal to 2. It's important to note that this is n minus 1 right here, but that's just a coincidence. It won't always be exactly n minus 1. It just happens to be in this case. Next, we have our magnetic quantum number. We want to go ahead and write out our D right here. And we know that our M value can be between negative L and positive L, which means in this case, M is going to be between negative 2 and positive 2. And D can hold up to 10 electrons. That's going to be 5 pairs this time. So 1, 2, 3, 4, 5. Not pretty, but it'll work. Next, we want to go ahead and look at how many electrons are in our orbital that we have right here. Actually, let's number these first. So we know it has to be between negative 2 and 2. So this is negative 2. This is negative 1. This is 0. This is 1. This is 2. And we can see that we have 2 electrons right here. So we're going to do up and up. Now, to figure out what your M sub L value is, you want to go ahead and look at which box is my electron in. We can see that in this case, it is above the negative 1 box. We know that M is equal to negative 1. And then again, to find the spin number, we want to look, is our last electron going up or is it going down? In this case, our last electron is going up. So our S is going to be equal to positive 1/2. Hopefully that helps. If you need any other examples, you can just ask me in the comments and I should be able to get back to them pretty soon. But otherwise, I think that will be everything.